The strangest visitors ever seen. In 2017, something extraordinary passed through our solar system. At the time, we didn't realize how historic that moment truly was. Earth had been visited by an object that did not belong to our star system. A traveler from the deep darkness between stars. It came without warning. It arrived silently, and it left us with more questions than answers. Now, in 2025, it's happening again. Another interstellar object is approaching our sun, but this time, we see it coming. And what we're learning may be even stranger than before. The first messenger. The first object ever confirmed to originate beyond our solar system was called Oumuamua. It had spent millions, perhaps billions, of years drifting through interstellar space before briefly entering our neighborhood. By the time astronomers realized what it was, the object had already passed the sun and was speeding back into the cosmic void. At first, it was classified as a comet, but something was wrong. There was no glowing cloud, no dust tail, no visible gas. Yet it behaved like a comet anyway, breaking the rules of gravity. Everything bound to the sun, planets, asteroids, comets, follows predictable paths. To escape the sun's gravity, an object must reach extreme speeds. When Oumuamua was detected beyond Earth's orbit, it was moving far too fast to be gravitationally captured. Its path was hyperbolic, meaning it was never part of our solar system. Even stranger, after passing incredibly close to the sun, inside Mercury's orbit, it accelerated instead of slowing down. Gravity alone couldn't explain this. Something was pushing it. A shape never seen before. Because the object was so small and distant, astronomers could only study the light it reflected. What they saw was shocking. The brightness changed dramatically every few hours, suggesting the object was not spherical at all. Instead, it appeared extremely elongated, possibly 10 times longer than it was wide, like a spinning rod or a thin, flat disk. Nothing like this had ever been observed in space. Comet behavior. Without a comet, normally, comets accelerate near the sun because heat turns ice into gas, creating jets that act like natural engines. But Oumuamua showed no visible outgassing, no tail, no coma, no plume, and yet it accelerated anyway. This contradiction sparked intense debate. Some proposed exotic physics. Others suggested unusual chemistry. A few even asked the uncomfortable question, could this have been artificial? Where did it come from? The object appeared to arrive from the general direction of Vega, one of the brightest stars in our sky. Vega holds deep historical significance. It once served as Earth's North Star, and will again in the distant future. There is no proof the object originated from that system, but the coincidence only added to the mystery. Oumuamua passed within about 24 million kilometers of Earth, close in cosmic terms, yet far enough to study only briefly. Then it was gone. Forever. A second visitor. In 2019, astronomers detected another interstellar object, 2I/Borisov. This one looked familiar. It had a coma. It had a tail. It behaved exactly like a comet. Still remarkable, but not unsettling. What mattered most was the pattern. For decades, we had seen 0 interstellar visitors. Now, suddenly, we had 2. And then, a third. The new arrival, 3I/ATLAS. The newest object is known as 3I/ATLAS. Unlike its predecessors, this one was detected before reaching the inner solar system. It is massive, it is fast, and it is coming from a completely different direction. Initial observations suggest it may be one of the oldest objects ever seen, possibly formed billions of years before our sun existed. Even more intriguing, It appears to originate from the Milky Way's thick disk, a region populated by ancient stellar remnants. A grand tour of the solar system. As 3I/ATLAS moves inward, it will pass near multiple planets. It will skim past Mars, then approach Venus. Later, it will pass close to Jupiter. Yet Earth will be on the opposite side of the Sun during the closest approach, meaning the object will briefly disappear from view. Some speculate. Most scientists remain cautious, but the trajectory is undeniably fascinating. Could we intercept it? Unlike Oumuamua, we have time. There is a slim chance that existing spacecraft, perhaps even Juno, could gather close-range data. Even without interception, telescopes will collect more information than ever before. And that matters, because understanding these objects means understanding how planets form, how solar systems break apart, and how material travels between the stars. A natural explanation. There is a compelling theory that Oumuamua was not artificial at all. Imagine a Pluto-like world made largely of frozen nitrogen. A catastrophic collision shatters it. A fragment is ejected into interstellar space. As it nears a star, invisible nitrogen gas sublimates, providing thrust without a visible tail. Bright,